Hi, good morning, my dears. I welcomes you for the today's session about hysteresis. What is that? Hysteresis. In the previous session, we discussed about what is magnet, types of magnets, and their properties. That is, dia, para, ferromagnetic materials we discussed in the previous session. We also compared this dia, para, and ferromagnetic materials in the previous session. Now we are going to see one more important character in ferromagnetic materials, that is hysteresis. Let's see what is it. It is defined as the lagging of magnetization or induction flux density behind the magnetizing force. What is hysteresis definition? It is defined as the lagging of magnetization or induction flux density behind the magnetizing force. That means it is a simple relation between B and H. The lagging of magnetization or induction flux density behind the magnetizing force. It also represents the relation between, that only we are discussing the previous slide only, this one, the magnetic induction B or intensity of magnetization of a ferromagnetic material with magnetizing force or magnetic intensity H. It represents the relation between magnetic induction B or intensity of magnetization of a ferromagnetic material with magnetizing force or magnetic intensity H. That means B to H. It is represent the relation between B and H. Let us consider what is exactly hysteresis. Let us consider an unmagnetized bar of iron AB. So what I am going to consider? Let us consider a unmagnetized bar, a unmagnetized rod, a unmagnetized specimen, that is iron specimen. It is not magnetized, it is a unmagnetized specimen. So this unmagnetized specimen of iron, it is named as what? AB. Iron AB is magnetized by placing with in the field of solenoid. So already we discussed what is solenoid. So what here we are doing? Let place a unmagnetized material, that is AB, placed in a solenoid. What is the purpose? To change into magnetized form. So this solenoid is changing this unmagnetized material into magnetized form. Unmagnetized bar AB, unmagnetized bar of AB, which is nothing but iron, is magnetized by placing it within the field of solenoid. In the field of solenoid, that unmagnetized bar, which is nothing but iron, which is named as AB, placed in the solenoid. Then what is happening? Solenoid is worked as an electromagnet, which can be converting this unmagnetized material into magnetized form. This is the schematic figure. You can see a rod AB. The rod AB is turned by number of wires, that's nothing but wrapped, and it is connected to the source, switch, power supply, that is battery, resistance R. So here that copper coil is wrapped around a rod. This rod is nothing but iron rod, but here In this case, iron rod is unmagnetized before sending the power. When power is applied to this iron bar or iron rod, then what is happening? That iron rod is changed into magnetized form. This is about the magnetization. In this magnetized form, the solenoid is producing certain amount of force that is called as magnetizing force. It is represented by symbol H. So during the magnetization process, H is produced, H is generated. That H is defined as magnetizing field force. It is equal to, it depends on two factors, that is H, the H depends on two factors, that is number of wrapping coil or number of woundings on the rod AB, and the current passing in the coil and the length of the coil. Thus so on these factors the H is defined or H is depend. The field H produced by the solenoid is called magnetizing force. Magnetizing force. What is magnetizing force? When the specimen is placed, what is specimen? AB specimen of iron. Whenever it is introduced in solenoid, the solenoid is producing or generating a particular field that is represented by H. The field H is produced by the solenoid is called magnetizing force. It is called as what? Magnetizing force. The magnetizing force already we discussed. It depends on N, I and L, number of turns, current as well as length. So the field is generating H. The field is generated by the solenoid and this field is defined as magnetizing force, where N is the number of turns on coil, I is the current, L is the length. The value of H can be increased or decreased by increasing or decreasing current through the coil. So here already we discussed H equal to Ni by L. Now the thing is that the magnitude or the value of H is may be increase or may be decrease. It may be increase or it may be decrease. But how? It is through the current in the coil. So the value of H can be increased or decreased by increasing or decreasing current through the coil. Increasing or decreasing current through the coil. Let's see. Let H be increased in steps from 0 up to a certain maximum value. What is that? Let, we are doing one activity. Let H be increased in steps from 0 up to a certain maximum value. The value of H is going to be increasing from 0 step to maximum step. What is that? 0 step to maximum step. In this process or in this activity, what are the flux densities values are generated that we need to analyze. So here what is that? HB increased in steps from 0 up to a certain maximum value, and the corresponding values of flux density, that is what, whenever it is increasing from 0, H is increasing from where to where, from the value of 0 to maximum level. So according to this H, from minimum to maximum or 0 to maximum, according to H, in B also certain values are expanding or certain values are generating. B also is showing some impactness because of the H. That will be, we are going to analyze in this series, that is the plot between B and H. If we plot the relation between H and B, what is that? If we plot the relation between H and B, a curve like OA is obtained. So what is that? So H is increasing or decreasing like that. As per the H is increasing, decreasing, there also it may be increasing, decreasing the value of B. So according to their increasing or decreasing, if you plot the relation is indicating so many curves in the structure or system. So like that, a curve is formed. The curve is considered as OA. So here you can see the figure, the whole systematic process. In the process of magnetization, in the process of demagnetization of iron, there are a lot of curves and structures are formed in the, for the complete cycle of the loop. There are a lot of structures are formed inside the system that we can analyze. This is about the activity. So the unmagnetized material, whenever it is magnetized, is showing certain modifications. When the magnetized body is demagnetized, it shows certain modification. That all we are going to see in the coming slides. So this is about the figure. Just you remember here the figure is having certain parts. Here no B, it is A, C, D, E, F, G. Okay. Here B is not included in the A series. It is A. The points are considered in this particular figure is A, C, D, C from up. A, C, D, E, F, G. B is not considered in this A, C, D series. B is here flux density, that is different. H is force, that is different. You should not consider in this series A and sorry B and H here, because we are going to plotting the relation between B and H. That is the reason we are not taking the B and H in our loop segment points. Okay, let's see. So OA is obtained, a curve is obtained, that already we discussed. Now see, the material becomes magnetically saturated for the H. So whenever we are magnetizing, so OA is a curve OA is generated. If you are further increasing the magnetization, what is happening? At the value of H, at the value of H, see you can see here from O to H. At the point of H, the body is saturated. At the point H, the body is saturated and has at the time maximum flux density of B maximum established. So at the saturation level, when H is saturated in the OM curve direction, in this particular direction, the B also having maximum flux density. Here at the saturation level, B is having maximum saturation value. The B is having maximum flux density value. If H is decreased, what is that? If the value of H is decreased, in the previously it is increasing, then saturated B also gaining maximum value. If the value of H is decreased, how H is decreased here? Because by reducing the solenoid current, if you apply more power to the solenoid, then the H value is increasing. If you apply less value to the solenoid, then H value will be decreasing. So here by decreasing the solenoid current, H value will be decreasing. Then what is happening? Flux density B is will decreasing, but not in AO direction. It will be decreasing in AC direction. It will be decreasing but not in AO direction. It will be decreasing in AC direction. It will be decreasing in AC direction. So when due to the solenoid current, when H is 0, due to the solenoid current, when H is 0, there is a decrement in the B value, but the decrement is not 0, it is having a certain value. When the value of H is 0 because of the solenoid current, most probably we are thinking that one, the value of B may be the value of B may be 0, but it is not happening here. Instead of becoming 0, the value of B is going to the minimum level, that is having a definite value. It's not gaining 0 value, it is getting a definite value even though when H is 0. So why? Because the value of B is not 0. Why? Because the value of B is not 0 because of, even if you reduce the value of H into 0 level, the magnetic material, the sample will have at least little to little, very less to less, it is having magnetic property. So that is called as a remanent property. So because of the remanent property, your value of B is not 0, that we can see here. It means that removing the magnetizing force, when H is removed, the iron bar is not completely demagnetized. So here that only we are discussing. When H is removed, means when the magnetizing force is removed, the iron bar is not completely demagnetized. So here iron bar is not demagnetized, even though when it is the magnetic force is H is removed. When H is removed, there is no, even when H is removed, sorry, when H is removed, when H is reduced, then there is in the iron bar no demagnetization process happening. Demagnetized iron is not demagnetized even if you are reducing the value of H, or if you are change the value of H into 0 level, the iron bar is not completely demagnetized. So this is known as remanence or retentivity. This is only known as remanence or retentivity. It is also called as a residual flux density. It is also called as residual flux density. It is also called a residual flux density, and it is represented by Br. It is represented by Br, residual flux density. And this residual flux density or remanence or retentivity will be indicated by OC curve. What is that? OC curve will be indicating this nature. OC is indicated. Now coming to the magnetized, now we are going to do activity of demagnetization. To demagnetize the iron bar, we have to apply magnetizing force in the reverse direction. What is that? The magnetizing force is in the reverse direction. To demagnetize the iron bar, we have to apply magnetizing force in the reverse direction. When H is reversed, what is that? When magnetizing force H is reversed, how it is reversing? By reversing the current through the solenoid. By reversing the current through the solenoid. When you shifting the terminals like positive to negative, negative to positive, whenever it is happening, then the magnetizing force H will be reversed. Then what is happening? Then B is reduced to 0 at point B. B is reduced to 0 at point D. B is reduced to 0 where H is, what is the curve path? At the point the curve path is OD. This value of H required, this value of H required to remove residual magnetism is known as cohesive force. Here, what is, even we are going to demagnetize, what I am going to do, we are going to demagnetize the material. In the demagnetized material, see in the previous, whenever it is magnetized, at least when the value of H is reduced, when the value of H becomes 0, the B is not 0. Instead of becoming 0, it is having certain value. So that is considered as a certain magnetic property it is possessing. That is the reason that is called as a remanent property. Here, in the demagnetization process means the magnetic material must be converted into demagnetized nature. Into a non-magnetic form, it must be converted into a non-magnetic form. For that, what activity here we done? So here H is reversed by the using of the sunlight concept. When H is reversed, what is happening? B is reduced to 0. The value of B is reduced to 0. At the value of H, at the point of H, that is nothing but curve OD, the value of H is required to remove the residual magnetism. So here, complete magnetism is removed in a magnetized body to convert the demagnetized material. So to remove the residual magnetism, whatever force is required, that force is called as cohesive force. What is that? Cohesive force. Cohesive. So here the magnetizing force is required to remove the residual magnetism. What is residual magnetism? When the value of H is 0, B is having certain value of magnetic property. The certain value of magnetic property in a B is called as residual magnetism when H is 0. To remove this residual magnetism, whatever magnetic force is required, that is called as cohesive force. It is measured as coercivity. It is measured as the measurement unit is what? Coercivity. If after the magnetization has been reduced to 0, what is that? So the magnetization reduced to 0. The magnetization is reduced to 0. After this, what will be happen? After the magnetization has been reduced to 0, value of H is further increased in the negative. So from 0 to it will be moved to the negative concept. The value of H is what? It is further increased in negative. Further increased in negative. If after the magnetization has been reduced to 0, the value of H is magnetizing force is further increased in, not in positive, further increased in negative. That means reverse direction. In the reverse direction, the iron ore again reaches a state of magnetic saturation, which is represented by L, which is represented by L. You can see in figure. That means reverse direction, the iron bar again reaches a state of magnetic saturation, which is represented by point L. Taking the magnetizing force H back from its value corresponding, taking H back from its value corresponding to negative saturation, which is what is negative saturation? L. From negative saturation OL to its value for positive saturation OM. So OM it is in positive saturation level, OL is negative saturation level. A curve, then what will be formed? A curve will be formed. The curve will define as EFGF. The curve is what? EFGA. A curve is formed. EFGA curve is formed. So this is OA. This is C point, D point, C, D, E, F, G, A. So a curve will be formed, that is E, F, G, A. If we again start from G, the same curve G, A, C, D, E, F, G is obtained. So this is a complete cycle process. It is a complete cycle process. If you further again start from the G, again a curve will be formed. The curve is named as GACDEFG. It is so from the above cyclic process, it is defined as, it is seen that B is always lag behind the H. B is always lag behind the H. The two B and H, the two parameters of B and H never attain to zero, never attain to zero value simultaneously, never attain to zero value simultaneously. So this is the reason this is called as lagging of B behind the H. Lagging of B behind the H. Lagging of the B behind the H. This is named as hysteresis. This is named as hysteresis. The closed loop ACDEFGA. The closed loop ACDEFGA, which is obtained when iron ore is taken through one complete cycle of magnetization. So here what is that? The closed loop ACDEFGA, which is obtained when iron ore is taken through one complete cycle of magnetization. Iron ore taken through one complete cycle of magnetization is called hysteresis loop. Is called what? Hysteresis loop. The complete one complete cycle function is nothing but hysteresis loop. Sorry, it is a spelling mistake. It is sorry, hysteresis loop, not a hypothesis. Hysteresis. This loop is what? Hysteresis. Hysteresis loop measures the energy dissipated due to the hysteresis. What is that hysteresis loop? Hysteresis loop is nothing but the energy dissipated due to hysteresis. The energy dissipated, that means energy loss. Dissipate means what here? It means loss. The energy loss. The energy loss due to hysteresis. The energy loss due to hysteresis. Hysteresis loop measures the energy loss due to hysteresis, which appears in the form of heat. Which appears in the form of heat. Which appears in the form of heat. The shape of the hysteresis loop. The shape of the hysteresis loop depends on the nature of magnetic material. Different magnetic materials will have, means ferromagnetic material. Different ferromagnetic material will have different hysteresis loop. Some will have large value, some will have narrow value. So here, the shape of the hysteresis loop depends on the nature of the magnetic material. The nature of the magnetic material. Let's see what is that. For example, you can see the figure. There is a broad. This is entire figure, loop 1, loop 2, loop 3, and the vertical one is the magnetization, the horizontal one is magnetic field. Magnetization and magnetic field we can see here. For the loop 1, so this is about loop 1. For the loop 1, that is about the steel material, hard steel material. For the loop 1, the hysteresis loop area is large. Hysteresis loop is what? Area is large. Hysteresis is low. Area is high. Hysteresis loop area is large. For the what? Reason is what? Due to its high retentivity, non double Y, single Y, due to its retentivity and collectivity, due to. So here what is the hysteresis loop is having? For the loop 1, there's a large loop is there. The area of hysteresis is very large. That means it is very large segment. So what is the use of this looped, very large hysteresis looped character material? It is due to its high retentivity and collectivity. It's good for making permanent magnets. It is good for making permanent magnets. This is the importance of the first loop, that is about the hard steel materials. Coming to the loop 2, it is about the wrought iron and cast steel. It shows that these materials have high permeability, good coercivity. High permeability and good good coercivity so that they can be useful for the electromagnets. They can be useful for the electromagnets. Moderate loss. Coming to the third one, that is very narrow shaped one. The hysteresis loop is very narrow. Loop is allowed there is for the steel. What is that? This is for steel, and it is good for the high permeability, low hysteresis loss. High permeability, low hysteresis loss. So that's the reason it can be useful in transform course. It can be useful in transform course, transformer course. Coming to the from the table figure, the relation between the soft iron and steel. Let's see what is that. The retentivity of soft iron is greater than retentivity of steel. The retentivity of soft iron is greater than the retentivity of steel. Soft iron is more strongly magnetized than steel. Soft iron is more strongly magnetized than the steel. Coercivity of soft iron is less than coercivity of steel. Coercivity of soft iron is less than coercivity of steel. Area BH loop for the soft iron is smaller than area of BH. Sorry, this is also BH loop of for the steel. Area of BH loop for the soft iron. Area of BH loop for the soft iron is smaller than area of BH loop for steel. Area of BH loop for the steel. Area of BH loop for soft iron is smaller than area of BH loop for the steel. So, hysteresis loss in case of soft iron is smaller than hysteresis loss in case of steel. So, what is the final word? We can conclude that one. Hysteresis loss in case of soft iron is smaller than hysteresis loss in case of steel. Hysteresis loss in the case of soft iron is smaller than hysteresis loss in case of steel. What is the significance of hysteresis loop? It provides information for us to such as retentivity, coercivity, permeability, susceptibility, energy loss. The hysteresis law can provide some information about retentivity, coercivity, permeability, susceptibility, energy loss. So these are the informations it will be provide about the retentivity, about the coercivity, about the permeability, about the susceptibility, about the energy loss. So these are the informations will be available by the from the significance of the hysteresis. That is the reason it can be. So this is about the ferromagnetic material. That is the reason. So the study of the hysteresis loops can be useful for the selecting a proper and suitable material for our purpose, for our requirement, whatever magnetic materials we need, that all magnetic material required data will be given by this hysteresis loop. This is about the hysteresis loop. So you can see the figure. So when you analyze the figure, you can easily understand total narrative concept. This is nothing but here a magnetized material, unmagnetized material, whenever it is placed in a sunlight, due to the effect of the sunlight concept, the unmagnetized material will be magnetized, because during this magnetization the value of H and value of B will be vary, and whenever the vary we are noting, and after noting the variation values of the B and H, if you plot a graph, it is indicating the relation between B and H, that is known as hysteresis. That is known as hysteresis. It is nothing but the relation between B and H. You can see here the point. So here O is the origin. So the unmagnetized material is placed in the solenoid, then it is magnetized. So a curve will be formed, that is OA curve will be formed. So here if you are further increasing the magnetizing level, so here in the right hand, in the on the x-axis in the positive direction, in OH direction, it will be saturated, that is positive saturation. Similarly, in left direction, that is OH, that is negative. So at the point of L, at the point L, you can see that one, that is negative saturation. Similarly, in y direction, there is a maximum value. B is a maximum value, that is a saturation level. Coming to the downside, B is also maximum value, but it is a negative value, negative maximum value. So here loop is existing, that is A, C, D, E, F, G. So this is called a complete loop. In this complete loop, you can see two characteristics. That is, one is a retentivity, the another one is a coercivity. What is meant by retentivity? So when you are reducing the value of H becomes into lowest level, like when the value of H is 0, what is happening? According to the value of H, there is also a B value also must be, as of our understanding, it must be 0. But here, in this particular case, the value of B is not 0. The value of B is not 0. Instead of going to be 0, instead of it is changing into 0 level, the value is the B is having certain definite value, means it is having little amount of the magnetic property, that is nothing but at least like 0.21, 0.1, 0.9 percentage of magnetic property it is having. Even if you are reducing the magnetizing force or H value into 0 level, it is having a little amount of the magnetic nature, that is called as a retentivity. Whenever you want to demagnetize the material, so here demagnetization can be happening by heating, by striking the material of the magnet. It can be demagnetized or demagnetized. Here our process, if you want, whenever it is demagnetized, the sample is demagnetized, that means the value of H is becomes 0. Sorry, the value of B must be 0, the value of B must be 0. So but here in the, whenever in the magnetizing process, it is having little amount of the magnetic property, that is called as retentivity. So to remove this retentivity character, whatever force is applying, that force is called as the coercivity. To removing this retentive property in a magnetic material, whatever force is applied, that force is called as the coercivity. So coercive force. So like that, in a complete cycle, retentivity as well as coercivity both will be happening. Retentive or remanent property or coercivity force, so coercive force or coercivity will be introduced will be introduced in the loops, this in this complete loop. So this is about the hysteresis. It can be useful to evaluate a good magnetic material for our purpose, to design a suitable magnet for our need. Whatever magnet we need, what the magnet need to get, what character it must be get, this all will be analyzed by this hysteresis. Thank you.